to talk about some of the key elements of the interplanetary spaceship and rocket booster. We decided to start off the development with what we think are probably the two most difficult elements of the design. One is the Raptor engine, this is going to be the highest chamber pressure engine of any kind ever built, and probably the highest thrust to weight. It's a full flow staged combustion engine, which maximizes the theoretical momentum that you can get out of a given source fuel and oxidizer. We subcool the oxygen and methane to densify it. So compared to when propellants are normally used, they're used close to their boiling point in most rockets. In our case, we actually load the propellants close to their freezing point, and that can result in a density improvement of up to around 10 to 12%, which makes an enormous difference in the actual results of the rocket. It also makes it gets rid of any cavitation risk for the turbopumps, and it makes it easier to feed a high-pressure turbopump if you have very cold propellant. Really, one of the keys here, though, is the vacuum version of Raptor having a 382-second ISP. This is really quite critical to the whole Mars mission, and we're confident we can get to that number, or at least within a few seconds of that number, ultimately maybe exceeding it slightly. And then I was really excited to see that the team managed to do the all-up Raptor engine firing in advance of this conference. I just want to say thanks to the Raptor team for really working 7 days a week to try to get this done in advance of the presentation. So I really wanted to show that we've made some hardware progress in this direction, and the Raptor is a really tricky engine. It's a lot trickier than Merlin because it's a full flow staged combustion, much higher pressure, and I'm kind of amazed it didn't blow up on the first firing, but fortunately it was good. It's kind of interesting to see the Mach diamonds forming. Yeah. So part of the reason for making the engine sort of small, like Raptor, although it has 3 times the thrust of a Merlin, is actually only about the same size as a Merlin engine because it has 3 times the operating pressure. And that means we can use a lot of the production techniques that we've honed with Merlin. We're currently producing Merlin engines at almost 300 per year. So we understand how to make rocket engines in volume. So even though the Mars vehicle uses 42 on the base and 9 on the upper stage, so we're 51 engines to make. That's well within our production capabilities for Merlin, and this is a similarly sized engine to Merlin, except for the expansion ratio. So we feel really comfortable about being able to make this engine in volume at a price that doesn't break our budget.